This video isn't going to specifically show you how to calculate limiting and excess reactants in a chemistry problem, but rather just going to give you the basic ideas behind the definition so you understand what the calculations are supporting. So as you look at these terms, limiting reactants and excess reactants, you should realize that we're dealing with values on the left side of an equation. So if you have an arrow, look at the two items on the left side of the equation, and those are the substances that we're dealing with. Now in this course, I try to keep it simple by only providing two reactants where one of them is going to be the limiting and one is the excess, but you should realize that in real life there are a lot more different scenarios that you would encounter. So whenever you do an experiment, a scientist doesn't necessarily precisely measure out every single reactant. So instead, you can add one reactant in excess, meaning one of the other reactant is going to be used up first. The reactant that gets used up first is what we call the limiting reactant or limiting reagent. It means the same thing. The other reactant is referred to as the excess reactant, and this is what you can add in excess. So it doesn't matter how much of it you add, you just keep adding until the reaction is over with, and that's what we call the excess reactant. So I always like to use food as an analogy in the stoichiometry unit because I think food is something that we all understand really well. So let's say my husband asks me to go to the grocery store and buy items to make a hamburger. What I would end up with at H-E-B is a pack of 3 buns. Even though I only need 2 buns, the smallest pack of buns I've ever seen at the grocery store was 3 buns, the Texas-sized buns. We also can go to the meat department and find a pack of 2 patties. If I wanted pickles, which I love pickles, I'd have to buy a whole entire jar. I'd have to buy a whole tomato. Even if I just wanted 2 slices, I'd have to buy a bag of lettuce and a bottle of ketchup to make burgers. Okay, so this is our basic analogy to for my reactants that will create a product of a burger. With this analogy, I ask you one question, actually 2 questions. So here's the first one. What will I run out of first? As you scan the reactants or the ingredients, you should realize that we are going to run out of patties first. There are only 2 patties, so that's going to limit us from being able to make more burgers. Patties are what we call the limiting reactant. If you run out of patties first, this is what we call the limiting reactant. For the next question, when I ask you how many burgers can I make, 2. We only have 2 patties. The patties are limiting us from being able to create more burgers, and this is the limiting reactant will always limit you from being able to make more product. While this next example is a chemistry example, it's sort of impractical because as you can see here, I have some whole numbers being presented to you. And in chemistry, we typically don't use whole numbers. It's not really practical in the lab setting, although we're just using it for simplicity's sake so that you can understand limiting versus excess reactants a little bit better in terms of chemistry words. Now, in this experiment, I want you to imagine that you're a scientist and that I'm hiring you to create NH3. Now, as I'm hiring you to create NH3, I'm going to supply you with some reactants, and I'm supplying you with 2 moles of N2 and 3 moles of H2. Here are the 2 moles of N2. Here are the 3 moles of H2. Now, remember that nitrogen and hydrogen are both diatomics. They're both Brinkelhoff elements, which means they must be attached to each other or a different element. Alright, so let's say you're creating some NH3. If you could get down to the atomic world and actually use up the atoms, pick them up, and form NH3, here's what it would look like. You would need 1 nitrogen and 3 hydrogens to make 1 mole of ammonia. To make another mole of ammonia, you would use up another nitrogen and 3 hydrogens, and then you would run out of hydrogen. Because we ran out of hydrogen first, that means that hydrogen is the limiting reactant. Because I still have some nitrogen left over, that means nitrogen is the excess reactant. So that's just a little bit on how we can understand the concept of limiting versus excess in a more visual representation. While this visual representation is up here, I just want to throw out that this nitrogen diatomic molecule cannot be split up and left split up. You either use both or you use none because nitrogen cannot be left alone. So in this analogy, I'm actually going to use dimensional analysis to show you how we can how we can figure out which one is the limiting reactant. So imagine I commission you to make some race cars out of race car shells and 4 tires. This is my balanced equation, by the way. So as I ask you to create some race cars, as I hire you to create some race cars, I'm going to give you 4 shells and I'm going to give you 13 tires to work with. And what we're going to do is we're going to use dimensional analysis to determine the limiting reactant. To start off, you're going to use one of these numbers. It doesn't matter which one you start off with. I always like to just start with the first number I see for no particular reason. So I start off with 4 shells, whatever's available. Then I'm going to do a mole-to-mole ratio from the balanced equation. 1 race car shell, the understood one, to 4 tires. Notice I always want to make sure that my units cancel out diagonally and my ratio is above and below each other. This calculation is basically going to show us how many tires we need if we had 4 shells. Okay, how many tires we need if we had 4 shells. Now, I actually told you that there are 13 tires available, so if you have 16 tires needed but 13 are available, do you have enough tires? No, you don't. And what that means is tires is going to be the limiting reactant. Tires is the limiting reactant. Therefore, shells are in excess.